Hello, myself Devyani Nikam. I am from third year electrical of Guru Gobind Singh Polytechnic Nasik. Today I am giving a PPT presentation on single phase induction motor. The contents are introduction, classification of induction motors, single phase induction motors, working principle of single phase induction motors, starting methods of single phase induction motors, resistance start induction run induction motor, capacitor start induction run induction motor, capacitor start capacitor run induction motor, shaded pole induction motor. Introduction. An induction motor or a synchronous motor is an AC electric motor in which the electric current in the rotor needed to produce torque is obtained by electromagnetic induction from the magnetic field of the stator winding. An induction motor can therefore be made without electrical connections to the rotor. An induction motor's rotor can be either wound type or squirrel cage type. Three-phase squirrel cage induction motors are widely used as industrial drives because they are self-starting, reliable and economical. Single-phase induction motors are used extensively for smaller loads such as household appliances like fans. These are some images of induction motors. Then the classification of induction motors. Induction motor can be classified as on the basis of rotor and on the basis of phase. On the basis of rotors, there are two types: squirrel cage induction motor and wound type induction motor. And on the basis of phase, there are two types of induction motors: single phase induction motors and three phase induction motors. In this presentation, we are going to see the single phase induction motors. Single phase induction motors. We use the single phase power system more widely than the three phase system for domestic purpose, commercial purposes, and some extent in industrial uses because the single phase system is more economical than a three phase system, and the power requirement is in most of the houses, shops, offices are small, in which can be easily met by a single phase system. The single-phase motors are simple in construction, cheap in cost, reliable and easy to repair and maintain. Due to all these advantages, the single-phase motor finds its application in vacuum cleaners, fans, washing machines, centrifugal pumps, blowers, washing machines, etc. This diagram shows the cross-section of single-phase induction motor, in which we can identify all the parts of a single-phase induction motor. There is motor shaft, a frame, bearing, end bell, cooling fan, end bracket bearing housing, rotor, armature winding, stator winding, and stator. The working principle of the single-phase induction motor. Basically, this single-phase induction motor works on the Faraday's law of electromagnetic induction. Single-phase induction motor's main winding is supplied with a single-phase AC current. This produces fluctuating magnetic flux around the rotor. This means as the direction of AC current changes, the direction of generated magnetic field changes. This is not enough condition to cause the rotation of rotor. Here the principle of double revolving field theory is applied. According to the double revolving field theory, a single alternating field is due to the combination of two fields of equal magnitude but revolving in the opposite direction. The magnitude of these two fields is equal to the half of the magnitude of the alternating field. This means that when AC is applied, two half magnitude fields are produced with equal magnitudes but revolving in opposite directions. So now there is a current flowing in the stator and magnetic field revolving on the rotor. Thus the Faraday's law of electromagnetic induction acts on the rotor. According to this law, the revolving field produce electricity in the rotor which generates force that can rotate the rotor. Starting methods of single phase induction motor. First, split phase motor. Second, capacitor start motor. Third, capacitor start capacitor run motor. Fourth, permanent split capacitor motor. Fifth, shaded pole induction motor. Resistance start induction run motor or split phase induction motor. The rotating magnetic field of the resistance start induction run motor is produced by the out of phase currents in the running and starting windings. Since the running winding appears more inductive and less resistive than the starting winding, the current flow in the running winding will be close to 90 degrees out of phase with the applied voltage. The phase angle difference between the current in the running winding and current in the starting winding of the resistance start induction run motor is generally 35 to 40 degrees. This is enough phase angle difference to produce a weak rotating field and consequently a weak torque to start the motor. Once the motor reaches about 75% of its rated speed, the starting winding is disconnected from the circuit and the motor continues to operate on the running winding. The contacts of the centrifugal switch are connected in the series with the starting winding. When the motor is at rest or not running, the contacts of the centrifugal switch are closed and provide a circuit to the starting winding. When the motor is started and reaches about 75% of its rated speed, a counterweight on the centrifugal switch moves outward because of the centrifugal force, causing the contacts to open and disconnect the starting winding from the power. The motor then continues to operate on the running winding. This diagram shows the phasor representation and circuit diagram of the split phase induction motor or resistance start induction run motor. Capacitor start induction motor. A capacitor start motors are a single phase induction motor that employs a capacitor in the auxiliary winding circuit to produce a greater phase difference between the current in main and auxiliary windings. The name capacitor starts itself shows that the motor uses a capacitor for the purpose of starting. The capacitor start motor has the cage rotor and two windings on the stator. They are known as main winding and auxiliary winding. Auxiliary winding is also known as starting winding. The two windings are placed 90 degrees apart. A capacitor Cs is connected in series with the starting winding. A centrifugal switch SC is also connected in the circuit. A capacitor start induction motor is a single phase induction motor which consists of a stator and a single cage rotor. The stator has two windings, that is main winding and auxiliary winding. The auxiliary winding is also known as the starting winding, and in construction these two windings are placed 90 degrees apart in space. The diagram shown below represents the circuit diagram and phasor diagrams of the capacitor run motor. In this phasor diagram, the IM is the current in the main winding which is lagging the auxiliary current IA by 90 degrees. Thus, a single phase supply current is split into two phases. The two windings are displaced apart by 90 degrees and their MMFs are equal to the magnitude but 90 degrees apart in time phase. The motor acts as a balanced two-phase load motor. As the motor approaches its rated speed, the auxiliary winding and the starting capacitor is disconnected automatically by the centrifugal switch provided on the shaft of the motor. Capacitor start capacitor run induction motor, which is also known as permanent capacitor motor. A capacitor start capacitor run induction motor is a single phase motor consists of a stator and single cage rotor. The stator has two windings, that is main winding and auxiliary winding. The auxiliary winding is also known as starting winding. In the construction, these two windings are placed 90 degrees apart in space. The capacitor start capacitor run induction motor has the cage rotor, and its stator has two windings known as main and auxiliary windings. These two windings are displaced 90 degrees in space. There are two capacitors in this method. One is used at the time of the starting and is known as starting capacitor. The other one is used for the continuous running and it is known as run capacitor. In this type of motor, two capacitors are used for starting purpose and other for running purpose. The capacitor used for starting purpose, CS, is the electrolyte type and is disconnected from the supply when the motor remains 75% of its synchronous speed and help the centrifugal switch S. Shaded pole induction motor. A shaded pole induction motor is a simple single phase induction motor which is self-starting with one of the poles shaded by the copper ring. The other name of the copper ring is shaded ring, where it acts as a secondary winding of the motor. It rotates only in one direction particularly and reverses movement is impossible. The shaded pole motor is the original type of AC single phase induction motor dating back to at least as early as 1980. A shaded pole motor is a small squirrel cage motor in which the auxiliary winding is composed of a copper ring or a bar surrounding a portion of each pole. When single phase AC supply is given to the stator winding, due to shading proportion provided to the poles, a rotating magnetic field is generated. This auxiliary single turn winding is called as shading coil. The construction of a shaded type induction motor is similar to the normal single phase induction motor. except for its stator poles. The stator poles of the stator pole motor are divided into two parts. One part of the pole consists of the short-circuited coil made up of copper, which is known as shedding coil or shedded part, and the remaining part is known as unshaded part of the pole. These windings are shown the cross section or shown the parts of the shedded pole induction motor. There is a stator main pole slots, copper wire, which is also known as shedding coil, shedded pole between the main poles, rotor, main pole slot, shedding coil, shedding pole between the poles, and the power source. Thank you.